Hello, in this video, we're going to focus on subtracting mixed numbers and improper fractions with unlike denominators. The first problem here, we have 6 and 7/15 minus 1 and 2/5. Our goal is to find the difference between these two numbers. Now, the first thing I notice is my denominators are not the same. When we are adding and subtracting fractions, we have to have the same denominator before we can begin adding and subtracting. Now, to do that, I'm going to start by identifying my denominators, which are 5 and 15. I'm going to list out the multiples to find my least common denominator. I'm going to start with my smaller number, and I have 5, 10, 15. And right away I see, wait, 15 and 15, this is great. That's my least common multiple, also my least common denominator. Now I like 15 because this is telling me I only have to change one of my fractions. Now, yes, you could use 30, you can use 45. Those are all great denominators as well. However, if I stick with the least common denominator, I only need to change one fraction, making my life a little bit easier. Now, the first thing I'm going to do is I'm going to take my whole numbers. I'm just going to rewrite them. I have 6 and 1. Now, I noticed here my denominators need to be 15, and that goes for my final answer as well. So sometimes I like to just write this out so I don't forget that I'm working with 15 as my denominator. I see 6 and 7/15, and I notice my denominator is already 15, so I do not need to change this. So I have 7. Now I have 5, here's my denominator, and I'm like 5 times what number gets me to 15? Well, 5 times 3 is 15, so now I'm going to multiply my numerator by 3 as well. 2 times 3 is 6. And last but least, I always look at my operation sign. My operation sign here is subtraction. I'm going to look at my numerators. I have 7 minus 6, which is 1. Now, in a mixed number, I cannot forget about my whole numbers. My whole number here is 6 and 1, so 6 minus 1 is 5, giving me a final answer of 5 and 1/15. Notice this is the same process you've been doing for adding mixed numbers and improper fractions as well. Always look at your denominators, find the least common denominator if they're not the same, create equivalent fractions, so now your denominators are the same, and then subtract your numerators, subtract your whole numbers, and you will get your final answer. And here's another problem. We have 7 and 9/11 minus 5 and 1/2. I'm looking at my denominators. I have 2 and I have 11. So let's see. I got to start by listing out my multiples. Well, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and I have here 11, 22. Now, many of you right away could have recognized, okay, we're going to use 22 as my least common denominator, which is fine. If you started with 11, you have 11, 22, and that's it. And you notice 22 is an even number, which means 2 is also going to work for this problem too. So now, looking back here, we have 7 and 9/11 minus 5 and 1/2. So I want my denominators to be 22. This is wonderful. I determined that on the side by finding my least common multiple, which is my least common denominator. Now notice here, I'm going to also include my whole numbers. Can't forget about those. So I have 11 times 2 gives me 22. So 9 times 2 gives me 18 as my new numerator. Now I have 2 times 11 is 22. And 1 times 11 is 11. Now, last but least, I look at my operation sign and I see that I'm subtracting. So I'm going to look at my numerators. I have 18 minus 11, which gives me 7. And my whole number, 7 minus 5, which is 2. So now my final answer is 2 and 7/22. Now notice, just like the previous problem, found my least common denominator, then found my equivalent fractions, then subtracted my numerators, then subtracted my whole numbers. Yes, that's a lot of steps, which is why writing this out is very, very helpful. For this problem here, we're going to solve this in 2 ways. It says, what is the value of 5 and 1/3 minus 4 and 1/2? Now, the first option is keeping actually both of these as a mixed number. In the next slide, we're going to change these both to improper fractions and then subtract. Both ways work because we know that every mixed number can be represented as an improper fraction, and every improper fraction can also be represented as a mixed number. So now we have 5 1/3 minus 4 1/2. Now, just like we've been doing all along, I look at my denominators. I have 3 and 2. So 3, 6, 9, 2, 4, 6, 8, 10, 12. But notice I didn't even need to continue going because I found, look at this, 6 and 6 are my least common denominator. Now, yes, you could use 12. That's not wrong. But using the smaller number keeps your multiplication facts that you're going to be working with smaller as well. So I'm going to rewrite my whole numbers, 5 and 4. I notice here I'm using 6 as my least common denominator, and that's going to be 6 in my answer as well. So now looking here, I'm like 3 times 2 gives me 6. So 1 times 2 is 2. Now here I have 2 times 3 is 6. 1 times 3 is 3. Now, we look at our numerators. We have 2 minus 3. Uh-oh, that's a problem there. We can't do that. We don't have enough to subtract from. So what we're going to do is we're going to borrow. Now, you've worked on borrowing with whole numbers. This is the same idea. In fact, within this mixed number, we're going to borrow from a whole number as well, which in this problem is 5. So I will do the borrowing in green so you can clearly see what's happening here. I'm going to borrow 1 whole from here, which is going to turn this into a 4. So now notice I took this 5 and I'm like, okay, I'm separating to 4 and 1. And I'm borrowing this 1 whole. Now, 1 whole, I look at my denominator here and I see that it's 6. This 1 whole can also be represented as 6/6. So now, if I was to add that 1 whole to my proper fraction here, instead of doing +1, I'm going to do +6/6. So now my whole number is 4. My new numerator is going to be 6 plus 2 is 8. My denominator is 6. Now, yes, when we work on adding mixed numbers, and even sometimes when you're subtracting, when you get something like this as your final answer, notice we have a mixed number with an improper fraction within it. It looks a little funky. It's hard to interpret when you have 4 and 8, 6. That sounds a little crazy having that improper fraction within the mixed number. However, when we're borrowing and we're in the process of solving, sometimes you want to convert your current mixed number to something that might look a little funky like this. But by doing this step, now we can subtract. So I'm just going to rewrite 4 and 3/6 again. Now notice this 4 and 3/6 continue to come with me. It didn't change. And now looking at my numerators, I can do 8 minus 3, which happens to be 5. Now I look at my whole numbers, 4 minus 4 is 0. Now you don't need to write 0 like this. In fact, since we have no whole numbers, you don't need to have a 0 to represent that there's nothing there. You can simply write nothing, and it clearly shows that there's no values as your whole number. So 5/6 is my final answer. Now let's say my final answer looked like a mixed number with an improper fraction in it, then you would convert it again and change it. But that step of changing this here now to a mixed number with an improper fraction is used to help us solve this problem. When you have to borrow, again, borrow from the whole number, take that 1. And notice I rewrote that 1 in another format. Now I chose 6 here because my denominator was 6. So now it makes it nice and easy when I want to add this 1 whole to 2/6. And now that's creating my new mixed number of 4 and 8/6, which is allowing me to now subtract my numerators because you can do 8 minus 3, which gave me 5, giving me a final answer of 5/6. Now, borrowing is great. Borrowing will be used when you're subtracting fractions as well, just like when you're subtracting whole numbers. You have to do it within your fractions as well. Now, you can choose when you're subtracting mixed numbers to keep it a mixed number, and you might want to go through the step of borrowing, which is great. You can also choose to convert your mixed numbers to an improper fraction. Now I'm going to rewrite 5 1/3 minus 4 1/2. I'm going to first convert these to a improper fraction. So 3 times 5 is 15 plus 1 is 16/3. And now I have 2 times 4 is 8 plus 1 is 9 halves. Now, just like we determined in the previous problem, we have 2 and 3, and we learned by listing out my multiples that 6 is going to be my least common denominator used in this problem. So now I know my final answer is going to have 6 as my denominator as well. I'm looking here and I'm like 3 times 2 gives me 6. So now 16 times 2 is going to be my new numerator. Now, some of you might know that answer. Some of you might need to write it on the side, and that's totally fine. Now I have 32/6 as my new fraction, which shows me this is all equivalent to 16/3 and 5 1/3. Now, I'm looking at 9 halves, and I see that 2 times 3 is 6. So if I multiply my denominator by 3, I multiply my numerator by 3. Notice it doesn't matter if you're given a proper fraction, improper fraction, mixed number, it's still the same process. 9 times 3 is 27. Now, finally, my last step, I'm going to simply subtract my numerators. 32 minus 27 is going to give me 5 as my new numerator with a final answer of 5/6. Now, when you are subtracting mixed numbers or improper fractions, when you have examples when you're borrowing, some of you might really enjoy borrowing, and that's wonderful. You are welcome to choose this format to solve. You are also welcome to convert this into an improper fraction and then solve. Both ways got us exactly the same answer. So you pick which way works best for you when you are solving these problems. No matter which way you choose, you're still going to get the same answer if you're solving it correctly. Now, as always, this video is posted on my YouTube channel. Feel free to refer to it at any time when you're working on subtracting mixed numbers and improper fractions with unlike denominators.